Hello, very good. We are now approaching the end of the day of discussions and talks. I understand that you all might be a bit more tired. I'll try to make this session very visual. There are many videos in the presentation and such, and that will surely help make it more enjoyable. The first thing is to introduce myself. Although Joan has already introduced me, I have been working at Plain Concepts for 15 years, currently as the CTIO of the company. I usually work with the research team at Plain Concepts, where we try to stay up to date with all the papers and new technologies that come out to try to teach these technologies through a POC to different companies, then try to create an MVP, and later try to bring these kinds of things to production, where we would then do a knowledge transfer to the rest of the company. This year in 2025, we have 4 research lines where we are focusing on Edge AI, Gen AI, digital twins, and the 4th is digital humans, which we believe is a new concept that has just emerged, and we think it will have significant development in the coming years. Today, what I would like to share with you in this session is exactly what we have explored in this area so far and where we are currently at in our progress. The first thing would be to say what we understand by digital humans, because until now, many times we talked about avatars, etc. And it's like a new concept that comes along to replace many of the things we knew and understood until now. The most common description you can find right now would be this: hyper-realistic avatars powered by advanced artificial intelligence, designed for highly realistic interactions that can simulate human behavior, offer deeply personalized experiences, and be utilized in a wide range of industries. There are a number of industries where they have started to be used, etc. But I tell you, it's like a concept they are exploring that is constantly bringing new things. And for example, at the last CES, the CEO of NVIDIA said this phrase, where he said to imagine a future where computers can interact with us like a human can. That is the reality, or perhaps the incredible reality, of digital humans that we have been talking. There have been many discussions today about agents. Well, the agent is this or not, or it's an agent that needs to have context, or an agent that needs to function autonomously, independently, etc. But think that today, to access the technology and many of these LLMs we are seeing, you need to write, you need to chat. There are some that you can talk to, but most of it is written, even to generate images, to do things. So where I think there will be a significant leap. I think it's a leap similar to when the iPhone came out, for example. I remember Steve Jobs, when he introduced the iPhone, he basically said, well, until now all phones have buttons. They have a stylus with which I can use the phone, but we were all born with the best pointer, which is our finger. And we launched the iPhone. Think about the revolution that caused, which is basically making that technology accessible to many more people, even people who didn't know how to write, etc. Well, today, although it may seem unbelievable, in this type of environment, not everyone is able to write using a keyboard and mouse. I think this is about imagining that this technology can be accessible from something more human, like direct communication or how we communicate with other humans. Here, for example, I was going to talk a bit about the challenges this entails. One of those challenges is facial realism. Why? Because humans and our brains from a young age are used to talking to people. We spend a lot of time looking at other people and engaging in conversations with them all day long. This constant interaction makes our brains experts in detecting human skin, recognizing hair, identifying eyes, and so on. One of the phenomena, I don't know if you know it, is the uncanny valley, which is it's called the uncanny valley, or that would be the translation. It suggests that we generally like things that resemble humans. However, when the resemblance becomes too close and something is just slightly off, our brain generates a sense of rejection. If it gets close but isn't perfect, there's a point where we no longer like it and it generates rejection. One of the examples, that example is on Wikipedia of a robot, and it's a very well-known problem in robotics, this thing that generates rejection when talking to that robot, etc. There are many more challenges. For example, temporal coherence. For example, body movement, that the animations are fluid, natural, that you don't suddenly see a finger turn around and do something that a normal finger wouldn't do, etc. Also, the topic of understanding and responses. It's important that it seems like it's understanding us, that we're talking to someone and we really get the feeling that it understands what we're saying. Another thing would be intonation. We don't speak like robots with a flat tone, but we really use intonation when we speak, when we emphasize certain words, etc. Lip sync is important. Although in Spain, I think, unlike other countries worldwide, it's not as important because we're used to watching all movies dubbed, and the lips don't really match what we usually see in movies. But in the rest of the world, it is much more important because you usually watch movies in their original version, and that makes you notice when something is not right. And if all this wasn't enough, all of this has to work in less than 200 milliseconds, which would be the response time a human would normally give you. No, we haven't managed to achieve this to date. It's a nice to have, what we would like to have. So where did we come from? I wanted to tell you a bit about where we come from to generate this, so you understand a bit the difficulty of doing all this. And first I was going to show you this video. Here, if you can lower the volume a bit. Here, for example, this is a startup that was born in Seville, a startup called Indices, which had the most innovative technology to interact with people, where they basically converted voice, sound into text, and then did semantic analysis of those phrases to determine what the user was talking about. As you can see, the first example was a two-dimensional video, but then they tried to make it even more realistic, and that's when the uncanny valley starts to emerge, and it was a bit more complex than this, etc. This startup was among those with the most cutting-edge technology worldwide, and it is a startup that in 2012 to 2013 bought Intel, and today has integrated into the environment they had, etc. And what happened? That since the uncanny valley generated that rejection, in the end, it hasn't yet been possible to reach that point of realism. So many companies have opted for what are three-dimensional cartoons, which you might know, for example, from Meta, when it recently launched its avatars, where within the applications you have an avatar that doesn't try to be hyper-realistic. So since it doesn't try to be hyper-realistic, it doesn't generate any rejection. You already assume that you're interacting with an avatar that really isn't a real person. For example, when Microsoft Teams presented their avatars, they didn't try to make them hyper-realistic. Why? Because if you don't achieve it, you generate rejection. And yet, working with these types of avatars is pleasant, and everyone assumes they don't have to be real. Here you can see, for example, in WhatsApp, what they have placed when they added them. But then, all of a sudden in the year 2022, ChatGPT was launched with its first version, and it turned out to be a complete revolution. As you can see there, ChatGPT reached an impressive milestone of 100 million users in a remarkably short period of time. It was a significant achievement in the industry. And it's true that ChatGPT changed everything, because all that was done until now of syntactically analyzing the sentences a person was giving you, etc. Now ChatGPT, almost fluently, gave us the impression that it could pass the Turing test, that well-known test of attempting such a feat. If I can give you a spoiler here too, as of today, not even the most modern model, ChatGPT 4, not even that model has passed the Turing test. I only think they did a test at the University of California last year, and it managed to fool 54% of the people, making them think it was human, but it didn't achieve 100%. Not even ChatGPT 4. But well, this was already a qualitative leap. So we, within the research team, who at that time were always thinking not about what is going to be done now, but about what is going to be done later, started thinking about an idea. Hey, why not take it so that I can talk to a mobile application, or I can talk to the computer that can be converted into, with a speech to text, it can be converted into text. We can pass it to a model like ChatGPT, like the GPT 3.5 model, I think it was. Then convert it back into voice and make it heard and directly, instead of you chatting with something where many people still chat with two fingers, etc. But make it much more fluid for the majority, or to reach many more people. And well, we embarked on a project we did for a client, a real product, which was basically a product to talk to a psychologist through a mobile application. We set up this architecture in Azure, where the key point here was mainly to address the issue of keeping the response time under 200 milliseconds. We didn't achieve that rate, but we got very close. And the way to achieve it was that at that time, models like Whisper had already come out to try to do speech to text and do it very well. But mobile phones, both iOS and Android, already have speech to text that works on the device in Edge and works very quickly too. If we had to send an audio file from the device to the cloud, it would take significantly longer than if we simply send text directly. So we did it with these recognizers that already come with the operating systems. Then in Azure, we used the ChatGPT 3.5 model. It had already been released, the 4 had just come out, but its responses were much slower than the 3.5. Therefore, we opted for the 3.5 because of the speed at which it could respond, since you wanted to have a conversation, not say something and wait 1 minute for it to respond. And then what we did was take the text response and convert it to voice using neural voice technology. And also an important thing we needed was the issue of visemes, which are basically the way you shape your mouth to say each of the usual phonemes in each of the words. With that, we created a 3-dimensional face, complete with all the muscles and bones. What we did was try to make each of those visemes so that when an audio was played on the mobile device, we would be able to interpolate each of those faces seamlessly. With that, it wasn't everything. We also needed, for example, when you talk to someone, you ask for something, there's nothing more unsettling than suddenly finishing talking and staying completely static, but you need some kind of idle animations. Or when you ask, if it's processing the response, it starts thinking or looks up or does something natural. And for that purpose, we utilized the iPhone's Face ID technology and captured a series of animations within the team that would help give it a sense of naturalness. And with that, we successfully created this innovative product, which is now available for download in both the iOS and Android app stores. We have named it Brain for a Company. It's not our own product, it's a product of that company, which basically gives you the opportunity to take a series of psychological tests with that virtual psychologist. Then at the end of the process, it makes a recommendation and provides you with a signed PDF that includes a certificate from the College of Psychologists of Spain, among other things. Vale. Besides this, after we worked on that, many more projects have come out that try to simulate similar things where you can somehow talk or generate and interact with this type of avatar. However, the problem is that they still don't look like a real human. You still perceive it as a video game character. It may be very well done, but it remains a character or a video game entity. After that, we made an effort to improve the avatars we had. Initially, we had created these avatars specifically for mobile topics. This was the original avatar, and we tried to enhance it by improving its materials and overall design. Here, for example, you see in the hair, in the ears, the translucency of the skin, that in video games, a technique called subsurface scattering is used to really simulate how light passes through human skin, especially in those parts where it is thinner, such as the ears, the nose, etc., the hair issue. But I can say that using this technique and using something that works in real time and with which you can talk in real time, the state of the art, using the best graphics that can be made with the best computer that can be made in real time would be this. It is a demo that we did, but well, it would be this. What is a demo that NVIDIA presented now in January? Although the skin looks very realistic and lifelike, etc., you see that it's not a person, you see that it doesn't deceive you. You can perfectly differentiate that it's not a person. I tell you, that's the maximum that can be achieved right now with the best PC. It wouldn't even work on the web or anything, but with the best PC in real time. So here, something different appears, which is that AI tries to improve everything that can be done or starts to cover many areas. And then it comes, hey, with artificial intelligence, there are models. And based on a lot of images, we can generate models or realistic photos. Very, very, very realistic. And that, as you all have possibly already seen, can be generated. So the issue of being able to generate photos that really confuse you and you really believe it is a human appears. I'm going to show you here, for example, the example of Aitana Lopez. I don't know how many of you are familiar with her, but she's a digital influencer who was created in Spain. She is an influencer who doesn't exist. I mean, a person who doesn't exist and posts daily photos on Instagram. She is an influencer who currently has 353,000 followers on Instagram, has billed 331,000 euros in 1 year. And the interesting thing about this is that it's known she doesn't exist. It says it is generated with artificial intelligence, and as you can see, is one of the most recent posts it has made. She made a post where she's seen playing paddle tennis, and suddenly it has 2,700 likes. The most unsettling thing, at least for me, is that it has 177 comments. Are there really people who have taken the time to write something to her? And when they write something, maybe they say, "Hey, what a good idea. I'm also going to play paddle tennis," or "Let's see if we can play together one day," and suddenly someone responds, "Hey, you know it's an AI?" And if so, so what? And it's unsettling because it's like she's having interactions with humans as if she were really a person. Moreover, this has led to, and this new technique using artificial intelligence has made this influencer earn so much money because they have done campaigns with Longuera that you say, wow, wow. A company that does something physical like cutting people's hair or dyeing hair uses a digital influencer to advertise. In this case, the marketing director of Longueras mentioned that it was much easier and had no limits working with digital influencers compared to real influencers. Because, for example, they wanted to give a real influencer a haircut or dye their hair a certain color, and maybe they have to pay a fortune because the influencer says, "Hey, I'm going to have this hair color for a month and I don't like it, so pay me more and I'll do it." And she said with digital influencers, we don't have that problem. We change the hair, put whatever we want, and so on. And what you are seeing there is a Longueras ad in Times Square using this avatar of Aitana Lopez. That would be like, in a static way, we have surpassed the possibility of creating static images with artificial intelligence that can confuse a human. The question is, will we be able to go further? There are other companies, I don't know if you know the company, the product Hagen, which is very well known, just like there is Synthesia, and there are a ton of products that have come out using artificial intelligence. One is Hagen, and the other day I remember watching a video on YouTube. This one caught my attention a lot to explain a bit about what can be done today, what cannot be done with Hagen. Okay, so as you see here, this product is called Instant Avatar. It has been launched by this company called Hagen, and you can create your own avatar. You upload a video of yourself with the webcam or with a video you record of yourself for 1 minute, and with that you are able to generate videos that try to use frames from that video in the correct way, to also try to adjust lip sync issues that are done afterwards and so on, to try to generate something very realistic. And it seems they have released it aimed at influencers. The issue with all of this is that you need to capture a real person, meaning it's not something completely invented from scratch. You need an actual person to provide their image in order to create that avatar, and you also need a voice to clone that voice. Additionally, you really have to pay rights if you want to use these elements, or you have to pay for all these kinds of things. So there, giving it some thought, this is one of the best things that can be done now with NVIDIA and such. Giving it some thought there, the research team remembered this, and we saw, I don't know if you remember this thing called NVIDIA Canvas, which is basically a concept where NVIDIA, hey, when you create an image with stable diffusion, if you only write a prompt is something very poor. Why can't you use as input, besides a prompt, more things so that the generation is richer, and above all, the control you can have over what is generated is more fine-grained. Because in a prompt, you don't have much control over what is generated. So thinking about this, having this idea in mind, we came up with this, and this is the point we are at right now with what we are investigating. We took the avatar we had created in 3 dimensions and thought, hey, let's do some lip sync tests with it. As you can see here, the lip sync is much better than what could be achieved in real time. This one is done with artificial intelligence. We took this image and thought, hey, what if we can improve it? I mean, it cannot be done in real time, but we can improve the lip sync and also make it look really human. What we did is, instead of generating models like VO2, like Sora, etc., we put in a prompt and generated a person to do something. And we could take and do a restyling with artificial intelligence, like changing the style of this avatar, and in that way better control the final style. With that, we generated these videos. That is the input video and the output video processed by artificial intelligence. As you can see, it's not generating directly, but rather using something as input, which is that 3-dimensional video generated with an avatar that then generates another one for us. Moreover, we might not change drastic things like the length of the hair, but we could change the style or the appearance of the person's face. And here, for example, the same input video, but a different prompt, and it generates a different video. And that, if you notice, it does get a bit closer to something we could think is more human. So we continued researching in this direction and realized that it wasn't necessary to have hyper-spectacular graphics, that with low-quality graphics, I mean graphics that could even work on a web with WebGL, you could then do the restyling. So we could create a web page where you could select different avatars, presets, hair type, hair length, etc. And not have to put all that information in the prompt, have that control, or suddenly say, I want short hair, I want long hair, and generate the prompt and do all that. Imagine on a web, and then that could be restyled and look really photorealistic. One thing we realized here, as seen in the video, is that she doesn't speak. And it's because we realized that instead of doing the lip sync to the 3-dimensional model and then doing the restyling, well, here you can see, I think the next one could be done at the end. That we could first do the 3-dimensional, from the 3-dimensional we would move to the restyling, and then we would do the lip sync with the sound and the voice and choose whatever we wanted. Moreover, once we had the animation, we could change the language. In this case, it was Japanese that was heard before. This is Chinese. Okay, so with all this, what we thought, or the idea was, hey, okay, so what would be the pipeline we are working on right now? How to take in 3D, as I said, have different presets where different people, avatars with longer hair, shorter hair, different types of clothing, etc. Make an animation about that, because the problem with Hagen when you say, I can't touch my nose, is because in Hagen, you can't, hey, just when I say a certain word, have the character touch their nose or point at you, or wink an eye, or do some kind of animation. The idea we are testing is to create those animations in 3 dimensions, with pre-selected avatars, with pre-selected animations, then take those animations and pass them to a model with a prompt to do a restyling of the model. What is the advantage? That now all artificial intelligence models only support 8 seconds of video, 10 seconds of video, etc. With this capability, we can generate video content. We can also restyle much longer videos with ease. Finally, if you notice, the mouth remains closed in the middle of the video. So then we choose a synthetic voice that we can generate with artificial intelligence. We set the prompt for how we want it to speak or what we want it to say. And we do the lip sync. This would be the pipeline we have been testing. And the result of all this would be something similar to the video I'm going to show you now.
Hello, I'm Anna from Plain Concepts Research.
Okay, as you can see, the result is much more realistic. We can also change the hair, for example, and with this 3-dimensional avatar, do the restyling, which would also look good. The idea is this can't be done in real time, which is our other option. We are trying to bring the other avatars to the web, and this technology is indeed feasible. It takes about 10 minutes or so to generate one of those videos locally, usually with models and such, because you have to process with several models a somewhat more complex pipeline. The idea is to bring this technology to companies for marketing messages. And there, it's not like in Hagen, maybe where we have to give up a face or give up a voice, etc. Instead, what you just saw is completely synthetic. There's nothing that has been used from a human. There's no body animation or anything. Everything has been generated in 3 dimensions. And that's it. This was a bit of what I wanted to tell you today.